Okay, in this example, this is kind of a cool one because it's tempting to look at this and say, okay, I have exponential and algebraic, so I'm going to let my u equal x to the 5th, and then my du will be a 5x to the 4th dx, and this all seems promising so far, but when I say dv is e to the x cubed, that is not simple. Don't try and trick yourself into thinking things are easier than they are. That's trying to find the antiderivative of a composition, and that is not something that is nice and easy to do unless you also have the derivative of the inner function sitting there. So this doesn't turn out to be a great choice. We can try switching it up. We could say u is equal to e to the x cubed, and it's not so bad to differentiate because we do have the chain rule. So we could say, okay, we're going to get an e to the x cubed, but we're also going to have to multiply by 3x squared. And then dv would have to be x to the 5th dx, and v would be 1/6 x to the 6th. So this looks kind of terrible to me, but let's just follow it through and see if it works. I do know another trick, and I promise I'll show it to you. So when I put this together, u times v is 1/6 x to the 6th times e to the x cubed minus the integral of v, I'm going to move that 1/6 out in front, x to the 6th du. Hold on, let's keep track. Okay, so I'm going to put the 3 out in front, and then I'm going to have an x squared e to the x cubed dx, which means I really have an x to the 8th. Okay, I think it's settled. I tried it. I followed through. And that looks worse than what I started with. So, I want to try something else. What I want to try is, we've already identified this as a composition. Let's first do a w substitution. So I want to substitute out the x cubed. And this seems a little shaky because substituting out the x cubed is not going to completely get rid of the x to the 5th. But just bear with me, I still think it'll do nice things. So my dw dx would be 3x squared, which means I can snag, I'm going to move that 3 to the bottom, I can snag 2 of these. Ooh, I erased more than I meant to. Okay, so look at it this way. I have an x cubed, an e to the x cubed, and an x squared dx in my original problem. So I am now claiming that the x squared dx can become dw over 3, and that the x cubed, and in fact both of the x cubes, can become u's. So this turns it, or w's, sorry. This turns it into w e to the w dw over 3. I'm going to move that out in front and make it a 1/3. This is a lot better. I still don't automatically just get to say what the integral is. It's not quite that obvious, but now I think a by parts would be extremely helpful. So now let's say u is equal to, okay, so algebraic trumps exponential, which means du is dw. This is one of those beauties where you can immediately wipe out one of the factors by taking a derivative, which means dv has to be e to the w dw, so v is just e to the w. So now, don't forget the 1/3. I have u times v, w-e, wow, e to the w, minus the integral of v du, which is 1/3 w e to the w minus 1/3 e to the w plus c. So I kind of did 2 steps at once. The antiderivative e to the w is still e to the w, and I distributed the 1/3 in there. Okay, I'm almost done. The only thing I have left to do is to recognize that w is actually x cubed, and that's going to need to show up if I'm going to have the right answer. So, moral of the story is often some combination of by parts and substitution is a really good idea. It can happen in this order, it can happen in the opposite order. Sometimes you'll do by parts and then substitution. In fact, I think we did that for arctan number, I don't know, 4 or something like that. So keep that in mind. I'm not saying that for every problem in this section you should use integration by parts and only integration by parts. Watch for places where substitution will help. And this is definitely one of them. Thanks for watching.